Good morning, everybody. How was your weekend? That's good to know. Now let's do the notes. In L1, put down the radius of the pizza, and in L2, put in the price. And what I want you to do is I want you to find the regression line, and you can write down the equation and write down what R is. So the equation, what R equals, and then we'll also do what the residual graph looks like. So first, put it in, and then do stat calc 8, and we'll see what happens. Alright, so when you get there, you get price hat is equal to negative 9.50 plus 3.19x, which is the radius, and R is equal to 0.982, which is very good. And then go to your stat plot and make your x1 equal L1, and y is equal to the residual, and make your scatter plot, sketch it out, and don't forget to do zoom 9. And I clearly get something that decreases and then increases, so I get my smile. So what we did the last time is we made L4 equal to the log of L2. Actually, we made it natural log. So do that now, and then do your linear regression between L1 and L4, and get the same information that we got from the last time. And we get y equals negative 0.062 plus the ln, and I really should use radius and price, but for right now we're just using y and x, and the natural log should have been for y, not x. So negative 0.062 plus 0.340x, and hit zoom 8 again so we can get the residuals. Not zoom 8. We actually want to hit zoom 9. And essentially, except for this one point, I get my points may be off, but I get a frown this time. So that means that this would have been the exponential regression, but the exponential regression didn't work. So now we're going to do the part in part C, which is the power regression. So L3 is equal to the natural log of L1. And then find the same information for the equation of the line, so the linear regression for L3 and L4, which means we have natural logs in both of them. My R, I forgot to get the R on the last one. The R over here was 0.990, and the R over here is 0.992. So I got the ln of y hat equals negative 1.47 plus 2 natural log of x. And when I take a look at the scatter plot with L3 comma the residuals, we get something that looks like that up there, and then down here, and then up. It doesn't look like a smiley face anymore. So this means that we are going to have the power regression because we took the natural log of both of them. So one of the things I'm going to do is I'm going to take this 2 and move it over here. So we got the ln of y hat equals negative 1.47 plus the ln of x to the second power. To get rid of the ln, we're going to use an e. So I got y hat equals e to the negative 1.47 times, because we can do the same thing we did in yesterday's lesson, or I'm sorry, Friday's lesson, where we separate these, e to the ln of x squared. Well, the e and the ln cancel out, so we get x squared, and e to the negative 1.47 turns out to be 0.229 x squared. So if you plug this into your equation and you do your stat plot, your scatter plot with L1 and L2, you should see that it comes fairly close. In fact, this is the picture that you get, and you can see that the curve really comes close to all of those points. Let's try it again with example number 2. In L1, we're using the length, and in L2, we're using the weight. So we're going back. This is the same stuff that we had from 12-2A. And to go back, sorry, I forgot to do the one last problem, which is, what is the expected price for a 14-inch pizza? So you just plug 14 in, and you get 0.229. Actually, this probably should have been 0.23. Times 14 squared. And so that turns out to be $45.08. Alright, back to this problem. I'm not going to draw them all out, but do the linear regression and then check the residual graph for L1 and L2. And if you see a residual graph that looks like a smile or a frown, that means that we have to go on to the next part. So when I have to find the linear regression first, and it says y hat equals negative 298.9 plus 25.2x, and I go to my residual plot right away, and x is L1, y is residual, and I'd hit zoom 9, and I see a clear smiley face just like I did for 12.1. So, linear, bad. Now we're going to try the exponential, which is L4 equals the natural log of L2. And then the linear regression between L1 and L4. And We need this at least to get the new residuals. And it says y equals 1.11 plus 0.159x. And I can just hit zoom 9 again because my residual graph is already set up. So zoom 9 it is, and we see a definite frown. Bad. So now we're going to put L3 equals the natural log of L1, and if this doesn't work, then we're all out of ideas. So ln of L1 for L3, linear regression L3 comma L4, and so the ln of y hat equals negative 4.37 plus 3.049 ln of x. Now for the residual, I have to go back to my stat plot and do L3 for the x, and residual is sticking with the y. And when I hit zoom 9, the graph looks like a whole bunch of points over there at the end, but it definitely doesn't look like a smile or a frown. So to transform this information back, I use E. I'm going to take this, move it up here. So this equals E to negative 4.37 times E to the ln of x to the 3.049. Those cancel. E to the negative 4.37 turns out to be 0.013 x to the 3.049. What is to predict the weight? So this really should have been a hat, and it really should have been weight hat equals 0.013 length to 3.049, and then we plug in 45 in here to answer part B. And it says 1,427.54 grams. Alright, so work on your homework, look at the practice test, have a good day. I'll see you tomorrow.